So, good morning, students. I am Y.S. Chandrasekharaya, Associate Professor of Physics, Government First Grade College, Tumkur. So, this is my fifth session. So, in this session, I will going to discuss the bending of beams, expression for bending moment. So, you are all familiar with the bending of beams. What is a beam? First of all, let us understand the meaning of what is a beam. So, beam is a metal plate or a metal bar whose length is large compared to its thickness. That is how we define a beam. So with the help of the knowledge of beam, now we have understood the meaning. If somebody asks what is a beam, so beam is a metal plate or a bar whose length is large compared to its thickness. That is how we define beam. So then bending of beam. So a beam is a rod or a bar of uniform cross section of homogeneous and isotopic elastic material whose length is large. That is what I have already explained. So then plane of bending. A beam may be considered as consisting of number of thin plane horizontal layers called surfaces placed one above the other. So now each plane layer or the surface consists of number of parallel longitudinal metallic fibers placed side by side and are called longitudinal filaments. Some of the filaments lying in the median plane of the beam remain unaltered in length and are called neutral filaments, and the median plane containing these is known as neutral surface. So now if we consider now I have explained the bending of beam. So if we consider beam is a metal plate whose length is large compared to its thickness. So in turn beam consists of some thin longitudinal filaments. So if you bend the beam, what happens? The upper layer of the beam gets elongated, whereas the lower layer gets contracted. The layers which are in between these two, they are unaffected by the external force we have applied. So the layers which are present in between these two, it is represented as a neutral filament, and the corresponding surface is called neutral surface. So now I will explain the neutral axis of a bent beam. So the plane in which bending takes place is known as the plane of bending, and obviously it is the vertical plane when the beam is placed horizontally. So the line attained by the intersection of the neutral surface and the plane of bending is called neutral axis. So this is a very important concept, because in most of the examination they will ask define neutral axis and neutral surface. So now I hope that you have understood the meaning of neutral axis. It is defined as the line attained by the intersection of the neutral surface and the plane of bending is called neutral axis. A line perpendicular to the plane of bending on which the center of curvature of all the bent filaments lie is called the axis of bending. So now I will going to derive the expression for the bending moment. So in order to derive the expression for the bending moment, we have to consider this diagram. So diagram in this sense, we have to bend the beam in the form of an arc. So consider the portion of the beam bent into a circular arc, or as shown in the figure, subtending an angle theta at its center of curvature C, and let the radius of curvature of the neutral axis is OO dash be R. It is represented by capital R, where R represent the radius of curvature of the bent beam. So let AB dash be a filament at a distance Z from the neutral axis as OO dash. The length of this filament in the unsent condition is equal to that of the neutral axis OO dash. So that means its original length is represented as AB, that will be is equal to R into theta. This is nothing but an arc length. So its extended length is given by A dash B dash. So that will be equal to R plus Z into theta. So that the increase in length can be calculated like this: A dash B dash minus AB, which gives you the increase in length, that is nothing but R plus Z into theta minus R theta. So if you simplify this, you will get Z into theta. So then the linear strain is defined as increase in length divided by original length. So increase in length is just now we have determined it is represented as z into theta, and the original length as the arc length, that is r into theta. If Q is the Young's modulus of the material, so then Q is defined as the stress divided by linear strain. So that stress can be written as Q into linear strain, that will be equal to Q into Z divided by R. So if delta into A is the area of cross section of the filament, then the tensile force on this area is given by delta A is equal to stress into area. So delta F will be equal to Q into Z by R into delta A. So moment of this about the neutral axis is given by delta F into Z, that will be equal to Q by R delta AZ square. So therefore total moment of the force acting on all the filaments is given by summation over Q by R into delta A into Z square. So summation over Z into AZ square, summation over delta into AZ square, it is nothing but AK square, where A is the area of cross section and K is the radius of gyration. So then therefore total moment of all these forces about AB are the bending moment of the beam is given by BM is equal to A Q AK square divided by R. It is as good as BM is equal to Q into IG, where IG represents the geometrical moment of inertia of the beam. So it is nothing but AK square divided by R, where R is the radius of curvature of the bent beam. So this is how we can derive the expression for the bending moment. So bending moment is always given by Q into IG divided by R. So with these things, I will conclude my fifth session. Thank you.